We are going to minimize the quantity 1 over x plus 1 over y. Let's say x and y are two non-negative numbers such that x plus y is equal to 5. We will begin by letting a function f be the sum of 1 over x plus 1 over y. This will be the value we are trying to minimize. Since we know that x plus y equals 5, we rewrite the equation for f into a single variable equation for f of x. Based on the given information that x plus y is equal to 5, solving for y results in 5 minus x. So we substitute 5 minus x into the original expression for y, as shown here. Given that x and y are two non-negative numbers, we can conclude that the domain is from 0 to 5, exclusive. Since f is continuous over this interval, and the graph has ends approaching positive infinity, then f will have an absolute minimum at a critical point. Start the process by finding a common denominator and simplifying the expression for f of x. Next, find the derivative, which is equal to f prime of x is equal to 10x minus 25 all over x squared times the quantity x minus 5 squared. Next, set the derivative equal to 0 and solve. Solving this equation for x, we get an x value of 2.5. So we know that f is minimized when x is equal to 2.5. We also need to know the y value for the minimization. To do this, substitute the x value we found into the equation. X plus y equals 5. Substituting 2.5 for x and solving for y gives us y equals 2.5 as well. So, we know the values of x and y. Let's substitute those back into the quantity 1 over x plus 1 over y and solve. Doing this results in f of 2.5 is equal to 1 over 2.5 plus 1 over 2.5, which is equal to 0.8. Therefore, the quantity is minimized when x equals 2.5. In this case, the minimum quantity is 0.8.